All right, 8th graders, we're going to start doing a new kind of proof. You've talked about two-column proofs, paragraph proofs, and so on. I'm now going to introduce you to a coordinate proof. Now, you have actually used coordinate geometry to find the midpoint of a line segment and to find the distance between 2 points. Coordinate geometry can also be used to prove conjectures. Let's make that smaller so we can have room for our next concept. Now, a coordinate proof is a style of a proof that uses coordinate geometry in algebra. The first step of a coordinate proof is to position the given figure in a plane. You can use any position that you want, but some strategies can make the steps of a proof simpler. So you're probably thinking, what are you even talking about? So before we go on, let me show you what I mean. Here's what I mean. You can place, let's say, a rectangle anywhere you want on this plane. So let's say when you have a rectangle, you can place the rectangle, for example, here. Or you could place it here. Or you could place it here, here, here. It does not matter where you place these shapes. You can place them whatever most convenient to you. So some strategies for positioning a figure could be: use the origin as a vertex, keeping the figure all in quadrant 1. Why? Because it's all positive. It may help you out. You could center the figure at the origin. You could center a side of the figure at the origin, or you could use one or both axes as sides of a figure. So example number 1, position a rectangle with a length of 8 units and a width of 3 units in the coordinate plane. And you can position it anywhere you want. So here are 2 methods. Method number 1, you can center the longer side of the rectangle at the origin. So you could put 8 units going at the bottom and make it an 8x3 rectangle. You could also, for example, use the origin as a vertex of the rectangle. So 0, 0 is the vertex of this rectangle. Maybe you want all positive numbers. It's completely up to you. Depending on what you are using the figure to prove, one solution may be better than the other. For example, if you need to find the midpoint of the longer side, use the first solution. Because it's centered, 4 units to the left, 4 units to the right, it's really easy to find the midpoint of the longer side. Once the figure is placed in the coordinate plane, you can use slope, coordinates of the vertices, the distance formula, or the midpoint formula to prove statements about the figure. So remember, this is a coordinate proof, not a two-column proof. So it's going to look a little different. So write a coordinate proof. So here's what we're going to do. We have a given. Write triangle ABC as vertices as shown. 0, 6 is A, 0, 0, the origin is B, and C is 4, 0. And then we know D is the midpoint of segment AC. I want to prove that triangle DBC is 1/2 of the area of triangle ABC. Here's our proof. You're going to kind of write it in a linear, like up and down type fashion. So we don't actually have to restate the given. But what we have to do is realize, what are we talking about? So we could say triangle ABC is a right triangle with a height of AB and a base of BC. So we have a good idea of what we're looking at in this picture. And since we're talking about area, we can say that we have a height of AB. Remember, we're not using the segment symbol because this is the length of AB and the length of BC. Since we are actually proving formulas like slope, vertice, midpoint, distance formula, etc., we're actually going to mathematically show that this is true. So the first thing I'm going to write down is the area of ABC. So the area of triangle ABC, any triangle, we have is 1/2 BH. Now remember, we plug in what the values are. So equals 1/2, B is 4, base of 4, height of 6 units, and that's going to give you 12 square units. Now I can say, by the midpoint formula, the coordinates of, and then we use the coordinates, D equals, that's the midpoint, 0 plus 4 divided by 2, 6 plus 0 divided by 2 equals 2, 3. We found the midpoint of segment AC. The y-coordinate of D is the height of triangle DBC, and the base is 4. So let's review this again. You are proving the area. So the first step was just proving the area of the big triangle. Now I have to find the area of the small triangle. Well, I have the base of the small triangle, but I don't have the height. So the height, to find it, we'd have to find the midpoint first. The midpoint is 2, 3. So the midpoint is 2, 3. Now you're like, well, wait, why do we have to do that? Because I can clearly see it's 2, 3. Because you don't know if it's 2 and 163 or 2 and 3.009. You have to mathematically first show it to me. So 2, 3. What does that mean? We now can find the area of this triangle. So we know the base is 4 units, the height is 3 units, and that gives us 6 units. So we have the area of the big triangle is 12 square units, the area of the small triangle is 6 squared units. So now we can make our final statement. Since 6 is half of 12, the area of triangle DBC is 1/2 the area of triangle ABC. You'll notice that most of this is words combined with formulas. You're giving reasons, but you don't need the typical 2-column proof formula. Now, a coordinate proof can also be used to prove that a certain relationship is always true. So they might not actually give you points. You can prove that a statement is true for all right triangles without knowing the side lengths. Keyword, right triangles. To do this, assign your own variables as the coordinates of the vertices. So example 3. Position each figure in the coordinate plane and give the coordinates of each vertex. So for example, a right triangle with a leg, lengths A and B. So length A, we could put it at 0, 0. We can put it wherever we want. So here, 0, 0. We know it's a right triangle, so that's why we put it with the axes here. So 0A would be length of A, and B0 would be a length of B. Over here, a rectangle with length C and width D. So C could be the length, D would be the width, and so up here, this point would be over C, up D. So there's how we could represent a rectangle with a length of C and D. All right, this is where it gets a little tricky. If a coordinate proof requires calculations with fractions, choose coordinates that make the calculations simpler. For example, use multiples of 2 when you are to find the coordinates of a midpoint, because to find the midpoint, you take half. Once you have assigned the coordinates of the vertices, the procedure for the proof is the same, except your calculations, instead of numbers, will involve variables. All right, example number 4, writing a coordinate proof. Angle B is a right angle in triangle ABC. D is the midpoint of segment AC. Prove that the area of triangle DBC is 1/2 the area of triangle ABC. Now, you'll notice, wait a minute, this is exactly the same thing as what we did in example 2, except now they don't give you any numbers at all. So I'm first going to draw the X and Y axes. We actually don't need a graph paper because we don't have numbers here. And I'm just going to draw a right triangle. Now obviously this is a very rough drawing. Now we know triangle ABC is going to be A, and then B I'm going to make the origin, and C. And then D is the midpoint, and so that would be point D, and I want to prove the same thing I did in example 2. But now we have different values. Here's what you need to know. I can let A be anything I want. Obviously it's 0 because it's on the y-axis. But it's completely up to you what letters you want to use or what anything I want to do. So I'm just going to say A. Since I'm going to have to find the midpoint, I want to use even numbers. So I'm going to use 0, 2, and then J. Now you're like, why 2J? We can't actually say 0, 2 because we don't have a number. So we have to let it be a variable. You could have said 2x or 2y, or you could have said 14y or 3y. You can let it be whatever number you want. but I'm using a multiple of 2, so it's easier to take calculations of it. So C, I'm just going to do, let's do 2n and 0. And then D we don't know. I've actually written out all of the steps. We're going to explain these. So step 1, I've already explained to you what I did with all 3 of these. Step 2 is position the figure, which I did. So now I'm going to write my proof. So we're going to say triangle ABC is a right triangle, and it's going to be a height of 2j and a base of 2n. So then we just say what the area is. The area of triangle ABC will be 1/2 base times height. So 1/2 base, which is 2n, the height, which is 2j, and so if I multiplied that, that gives me 2nj square units. Now you're like, what in the world is that? Because at the end, you're going to see what's going to happen. Then we need to find the midpoint D. So to find it, we plug everything in, we add the x values together, take half, we add the y values together, take half. That gives us the point here for D as nj. Now, the height of DBC would then be what? If we go over n and up j, that means the height's j. So the height is going to be j. B, the base of the triangle, is 2n. So 2n times j and take a half of that would be nj. And so if you look, we have 2nj square units for the big triangle and nj for square units for the small one. Therefore, since nj is half of 2nj, the area of triangle DBC is 1/2 the area of the other triangle. The only vocab word today is coordinate proof.